Afternoon, everyone. Welcome. My name's Adrienne Brown, Professional Development Coordinator for the District Academic Senate of the Los Angeles Community College District. And I'm here to welcome you to today's event through the Sustainable Environment Institute. The vision statement of the Sustainable Environment Institute is to advance the principles of sustainable living through teaching, practice, and community participation in the belief that the application of these principles will lead to an enduring and more equitable society. So I'm very excited to see all of you here today because these topics are so important for all of us since we only have one planet. So let's get chatting about it and welcome to the discussion.
Thank you, Adrienne. And welcome to the Sustainable Environment Institute seminar series organized with the College of Professional Development. Thank you, Adrienne. And also this particular time, we're also working with the California Center for Climate Education at West LA College, who have sponsored today's speaker, Didi Pershouse. And we have a very interesting, very unusual talk for you today that is different than a lot of what you might be used to with the SCI series, because we're going to really feature ideas that Didi Pershouse has worked on that are bridge a very important gulf between, you could say, mental well-being and ecology. But before I get too started there, let me remind you of a few things. I can maybe share the screen here to show you that we have a film festival that started at the beginning of this month. It's online. It has many, they're all free, and you can access that film festival by clicking on the links that are available on this particular poster on our website. So our website, which also appears behind us here, is seilaccd.net. Very simple one. And because we have two events today, we have both the film festival on this side and Didi Pershouse's presentation today on the right side with all the appropriate links. I also want to direct you to where we record these events and where we keep some kind of repository. And so for today, for instance, we have soils equals public health equals environmental justice with Didi. And eventually we'll have the recording of this event here, as well as links to her own website and some of her publications, as well as some of the groups that she participates with, like the Land and Leadership Initiative. She has an interesting take on rehydration and on the hydrologic cycle, which we'll learn about today. And there's also a short video clip that she produced on YouTube for her YouTube channel. So those are all available on this tab up here that says the lecture series, and then we feature these have been ongoing for many years, and we keep them all here as a repository for faculty to use in whatever capacity they want. So that's the film festival. And then on May 16th, upcoming, we have embedding climate literacy into the curriculum. This will be the last of our series for the academic year, and we hope to share that with faculty as we make big efforts statewide to get the Sacramento to fund community college climate education. Which is, as you probably know, sorely lacking when it comes to the budget in Sacramento. And of course, it's not easy, but we'll learn all about that on May 16th and what progress we've made there. Always direct you to our website, which has as much up-to-date information as we can, including, for example, an events page that is all of upcoming events that we get notified by different organizations. We try to feature those that are free of cost. If there is a cost, it's usually minimal, and they involve a lot of our local nonprofits. We also have our current newsletter for April, which came out earlier this week. And of course, it features Didi's talk for today at the very top, as well as a short article about Didi's work with links to many of her publications. So I encourage you to visit our newsletter if you haven't received it in your email already. And you can see that we have a lot of content. These are called updates. They aren't meant to be exhaustive, but we do feature things, for example, our Gold Creek Ecological Reserve up in Little Tujunga, which is an ecological study area that is organized managed by the LA Community College District. And we also have an article from our sponsor today, which is the California Center for Climate Change Education at West LA College. And Joe Tavares has been kind enough to share some of their milestones and where they are today. So that is our newsletter. And there is a survey that we're asking you to fill out at the end of today. And I think maybe Zhao might give you some more details on that. We're also encouraging people to log in with their real names because we do give professional development credit, flex credit to faculty. And that's why we've allowed you to rename yourself, because often people log in as someone else and then we don't give them the credit because we don't know who they are. And that would also apply to any of my students that are attending from my class at Valley College or Woodbury. If you're here, rename yourself with your real name. Thank you for allowing me to walk you through that introduction. Beth, Zhao, is there anything I'm leaving out? This time I did take notes.
Nope, I think we're ready to go.
Good. Okay, thank you. So with that, let me make sure my this expression goes, my ducks are in a row. So I will share screen and take you to what is I'm understanding from all of my colleagues on YouTube that these are required disclaimers, because you'll see today that I've used a few clips that are fair use from mostly from PBS NewsHour, and they have a whole discussion on efforts to regenerate agriculture in the Midwest. It's very interesting. So this is being recorded, and we're of course glad to let you know that the recording will be available earlier or later on in this weekend. And so today we are listening to a very interesting talk that combines soil, you could say soil science, soil ecology, with concerns for humans' interaction with soil, which is really the issue of how healthy are we, and of course the maldistribution of environmental bads, if we want to use the term used by economists, and that brings up the issue of environmental justice. Where are people most affected? And we'll hear from Didi today. She will actually share with us a view of Los Angeles that will really underscore the differences in this city, which has probably the widest gulf of wealth in any city in the United States is actually found in Los Angeles. It has the highest concentration of billionaires and the highest concentration of unhoused people, rivaling, I think, we're close to 70,000 unhoused people in Los Angeles County. These are all links to Didi's work. This is a short article from Vandana Shiva talking about that link between biodiversity-based agriculture and the climate crisis. And you'll see that this dovetails beautifully with Didi's talk today. So the problem of food production in the industrialized agricultural model is something that Didi has addressed directly, and you'll see that she is not alone in this effort to bring about what is known as regenerative agriculture. It exists on all different kinds of scales, from the very small experimental scale to the large wholesale transformation of the soy and corn complex in Iowa.
Iowa's farmland is used to grow corn and soybeans, most all of it through what's known as industrial agriculture, using expensive equipment and a massive amount of chemical fertilizers and pesticides. Those two crops are highly subsidized by the federal government to the tune of hundreds of millions of dollars a year. And corn and soy are mostly grown to produce ethanol and animal feed. The remainder that's eaten by humans is mostly in the form of junk food. Sarah Carlson is the Strategic Initiatives Director at Practical Farmers of Iowa, or PFI.
Nature doesn't like all that specialization, right? Nature wants chaos. Nature wants diversity.
PFI is a farmer-led nonprofit organization that researches conservation practices, shares the findings with its members, like Sam Bennett. When people think of Iowa, the reality is it's not much more than corn and soybeans. Is that a problem? Or if it is, why is that a problem?
So because of the cropping system that we have today, where we just plant 2 crops for about 6 months out of the year, we have no roots in the ground in the wintertime. And so we have a lot of chance for water to take pollutants into nearby water bodies.
Pollutants called nitrates, found naturally in soil and also contained in fertilizers, have contaminated Iowa's drinking water supply. It's costing hundreds of millions of dollars to clean it up.
Also, we have increased flash flooding because we aren't holding water on the landscape like we used to.
Record flooding earlier this year left swaths of farmland throughout the Midwest too wet to plant, threatening many farmers' livelihoods. And the use of cover crops has surged in this state, tripling over the last 5 years to around 900,000 acres today. Carlson points out that, ironically, many of these practices used to be common. Industrial farming of corn and soybeans is actually a relatively new phenomenon.
We haven't always looked like this. Even 3 decades ago, farmers in this area would have been growing small grains in rotation with a legume cover crop and corn and some soybeans.
Iowa used to produce a huge amount of horticultural crops. So it produced apples and grapes and tomatoes.
Matt Liebman is a professor of agronomy and a researcher at Iowa State University.
Many species have declined precipitously. So the Iowa landscape began to transform dramatically in the 20th century. And with the development of farm chemicals and machinery, crop rotations got much less diverse and enormous increases in productivity took place. And that's what we're living with today, a highly mechanized, extremely specialized, highly productive, narrow diversity system.
This highly mechanized system is depleting Iowa's nutrient-rich topsoil. About half of it has already disappeared. Liebman is researching ways to combat the destruction by growing something called prairie strips, plots of native grasses and wildflowers planted alongside traditional crops.
This one is called Illinois bundleflower. It's a legume. There's something covering the ground year round. And these plants have stiff, upright stems that serve as ways to filter water flowing across the land, slow it down. There's a lot of vegetation here. So there's essentially no runoff off of prairie.
So farmers feel trapped in this system. But despite all the hurdles, people like John Eichert say we don't have a choice but to change. Eichert is an agricultural economist who spent 30 years working with farmers across the U.S.
I can't tell you how long we can continue to prop up this unsustainable agriculture, but we can't do it indefinitely.
What does a sustainable food system look like?
It's about looking at agriculture as a part of a living system because it's all interconnected. And so you have to have farming systems that function in harmony with nature, with natural principles. The regenerative, resilient, diverse natural ecosystems have to be reflected in the farm.
So what will it take to make the large-scale changes experts believe need to happen? PFI's Sarah Carlson says food companies can create markets for alternative crops, and state and federal governments must increase sustainability requirements in farming programs.
It might be through finance, it might be through mortgage rates, it might be through the market, it might be through crop insurance. So we've got to try all of those things and see what gets the shift the fastest. If we care about farmers on the landscape and we care about rural communities, then we need to kind of make a wholesale change in the way we do business and the way we support agriculture in general.
But all of that is a long way off. For now, farmers like Sam Bennett are implementing solutions crop by crop, acre by acre.
So I mentioned earlier that indeed Didi is not alone. She is part of a very broad and important movement in addressing the failures of American agriculture as an industrialized system that emerged in the 20th century. So with that, I want to turn it over to Didi Pershouse, who I think bridges all of these things that we've just looked at. It's very fortunate that we have someone who's dedicated her whole life, intellectually speaking and spiritually speaking, to developing, exploring, implementing the needed changes that we've just heard about. So with that, let me put Didi in the middle there and turn it over to her. Thank you, Didi.
Great. Thank you, George. Those were great clips that makes my work a little easier today because there's a lot to explain here. And there's a lot I want to know as well. Let me just share this PowerPoint here. So we're talking about soil health, public health, and environmental justice, which is lots of things together. And yet the way that systems work is that everything does influence everything else. So we could put really almost any 3 issues in that little box and figure out how they are interrelated. This particular set been of great interest to me for a while. I don't usually mention my book much, but today's topics really do touch on it exactly. I spent about 9 years, the last 9 years of my holistic health practice working on this book, The Ecology of Care, Medicine, Agriculture, Money, and the Quiet Power of Human and Microbial Communities. And it's looking at how our economic systems and our social systems have created what I call sterile paradigms of care for both people and land, and that the way that we care for land hugely impacts people and our ability to care for each other. And that different economic models, different land care models, and different healthcare models can impact those microbial communities and human communities and plant communities and ecological communities in such a way that we can actually bring it all back together. I know what you were just watching sounded pretty dire, and it is pretty dire, but there are actually a lot more solutions out there than we hear about very often. And I'll explain part of why that is. So I wanted first just to invite Beth Abels to give me a quick little tour of LA from the perspective of soil, water, and public health, and the sort of environmental justice lens of it. I did this with a group earlier, so I've had a little preview, but I thought it might be nice to just ground us in reality, because it's very easy to get theoretical about these things and not be giving real examples.
So Didi, I'm gonna put Google Earth up. Yeah.
Yep.
And then we'll take a look and see all about our beautiful city. So can you all see that?
Yes.
Great.
And if you click out that X that says Sea Help Center, that bar across.
Yeah, we'll make that go away.
A little more room. Yeah.
And I can stretch it out a little bit more. Wasn't sure what it was going to look like. There
Yep. And you can also pop in that little arrow on the left, so that left hand untitled and goes away. Go down to the middle in the map.
Sorry.
No, I've learned this in the last month while we've been doing lots of mapping exercises.
Haven't been working with this enough. Yeah. Okay.
Great.
So this is Los Angeles. It's not just a city, it's actually a clump of many cities that are kind of interacting with each other and intermingling with each other. So this is kind of the out view of the basin, and I'm going too far because Los Angeles comes up here, and this is our San Fernando Valley, and this is what we refer to as the basin of LA. These are the Santa Monica Mountains, and they are a transverse range, so they create some interesting patterns and help make our city and our area what it is weather-wise. San Gabriel Valley is up here, and then we move out of actually the city of Los Angeles, but our San Gabriel Mountains are here, and that's a natural forest, and Santa Monica Mountains is actually a national park. So poverty, income, all right. So generally our coasts are wealthier, and then some of our mountain areas are wealthier. But so coastal area more tends to be a little bit more green. So we zoom in a little bit, but that's not a lot of green. Here is beautiful Pierce College, all the way up here in this little space. This is the San Fernando Valley again, and you can see what we think of as green is actually open space with dead stuff on it, dead grass. But but we don't have a lot of, within the fabric of our cities, we don't have a tremendous amount of open space.
Mhm.
We have Griffith Park is over here, and that's kind of still open space and parkland. This is, I want to say that's UCLA. And I want to say that, but probably I shouldn't because I'm not sure. So these are wealthier neighborhoods along here. This is the 405, so kind of west of the 405 tends to be wealthier, east of the 405, except for Beverly Hills and other areas like that. Then there's little pockets. So downtown Los Angeles area, super dense, and then East LA as we
Can
get.
we zoom right in there?
Where would
So
you
what
like
I'm
to go?
looking at is kind of the downtown areas that have less vegetation.
No vegetation, right? So
Or, you know, or some of the neighborhoods where there are sort of lower income neighborhoods where they have not been, you know, there aren't lots of parks or trees or backyards
Yeah.
or swimming pools or that kind of thing.
So this is, I think, where we start to see the fabric of more South Central Los Angeles. I do have to give you a heads up for South Central Los Angeles. The Los Angeles Police Department have told them that trees cause a dangerous neighborhood. So if you have trees in your neighborhood, it means there's hiding places. And so LAPD is kind of pushed the removal of green areas, green trees
Wow.
in the more lower income neighborhoods.
Hmm.
Okay, this is Vernon and City of Industry, and then the LA River is considered open space, is what we are looking at very actively as open space. Because as you start to see, so this is this area is I'm trying to think of the name of it because I always take students here. It borders with Industrial City Vernon, and so the permitting process here is much different than it is here. But there's this is the densest area in the Los Angeles basin, one of the most high levels of most residents in the least amount of space, and they have this and these little teeny patches of green space. So mostly schools.
Can you zoom right in there? Just get a sense of the buildings. Yeah.
So spare, and that, you know, I think this is super dense, but I think this is generally, you'll see the fabric of most of Los Angeles has this quality to it.
Yeah. Yeah. Great. Okay. I mean, I don't mean great for that, but I mean great. Thank you for the tour. Okay. Why don't we are limited on time, and there's a lot to talk about here. We might come back to the map later, but thank you for that.
Welcome. Got my share here.
Great. Okay. So when people talk about climate change, from what I'm understanding, there's a lot of concerns about heat, and some of the folks I talked to this morning who were in LA were telling me that there is a 20 to 30 degree temperature difference on hot days between sort of inner city and the more coastal northern, I forget what you call that area, but there's sort of Santa Monica area. With heat itself, we know that there's just enormous public health issues simply with heat. And that impacts all kinds of human health aspects, including mental health. But we also have a lot of other issues right now. We have a lot of air quality issues, right? Which impacts breathing, asthma, allergies. It impacts actually mental health. Air quality influences like levels of dementia and neurological diseases. And we have flooding and drought, right? Other climate related issues. So we have issues around sea level rise. We have issues around kind of the type of weather and storms and how long things last. And then huge issues around fire, right, in your region, maybe not so much right in the city, but certainly all around that area. Water availability, and so water sovereignty, water security, food sovereignty, food security, issues with food deserts, and then huge issues just with nutrition, right? Part of what George was showing was that most of what's grown these days is either for feedlot animals, which are unhealthy both for them, for us, and for the climate, but also for junk food, you know, high fructose corn syrup and that kind of thing. So those are some of the issues that we're looking at, and we could go on quite long about that. What I want to talk about first here today is what does this weird little blobby thing have to do with all of that? This is what I call the soil sponge, or you could also talk about it as soil structure and function. So the sort of matrix of soil structure that creates soil function and that creates the function of a whole landscape. And the function of the entire land-based part of the earth is part of how our own structural and functional capacity and our own aliveness happens. And as Sadhguru was saying there, that it's, you know, if you just have sand, silt, and clay, if you just have these little broken down rock particles and you don't have life holding it together with these slimes and glues and threads and root hairs, etc., then not much happens, right? And we'll look at that in just a moment. So what's special here that I want you to notice is two things. One, that the little sand, silt, and clay broken down rock particles are clumped together into aggregates. So it's, if they were people, they'd be all standing in little clumps in the room and there'd be space around them. They're also tied together with, these are mycorrhizal hyphae, which are like something in the mushroom family, but doesn't actually sprout mushrooms. They grow out of plant roots and go search out nutrients for the plants, but they also help to tie these little soil aggregate clumps together. And then the other important thing is the space. So I like to call this sacred space underground. And space is really important because what can happen in space is air for all the life underground, so oxygen, as well as it can hold water. And part of why we talk about this as a soil sponge is that, like a kitchen sponge, it holds together when it's wet, but it can also hold water. So if every time you put your kitchen sponge in the sink, it fell apart, it would not be a sponge. And if it didn't have any holes in it, it would also not be a sponge. So why is this important? Why does this have to do with all the things we just talked about and more? Well, guys, sorry, this was for the sacred space. I like to think of it as if I was a little soil microbe, I think it might look this beautiful to me under there. So here's a way that we can actually see it in action, but we can do this like at a dinner party or at a meeting, etc. Is to take a plate of flour and think about that as degraded soil. It's gone back to that kind of sandiness. And we're going to take a cup and poke some holes in it and see what happens when it rains on this landscape. Huh, did it stop? Hang on. Here we go. Okay. So if you've done any baking, you know when you have just a plate of flour and you pour water on it, it doesn't soak in, right? It just runs off. And when we have degraded soil, it is not aggregated. It's not a soil sponge. It's just those sandy particles like you might have in a dusty old lot. This is what happens when it rains, is that the water just runs off. It takes some of the soil with it. Like we were saying, we're losing soil every year, tons of soil per acre. And nothing soaks in for the plants. We have flooding and drought at the same time. Put this out in the sun, it starts to seal off, and you actually have less ability to soak in water the next time. The water, the LA River, to wherever the water's going, is full of soil, full of chemicals, full of whatever's on the surface. And it's problematic. It's problematic for growing food. It's problematic for keeping water in the soil for the future. And it's problematic for the bodies of water. All right, but what do we need to do to turn flour into bread? We add biology, right? So it's a little different with soil because it's a lot more different biology, but the structure and functional aspects of it are the same. That suddenly we go from something that's kind of powdery and loose and that would blow away if a big wind comes along, to something that has a structure to it. And if we rain on that, something entirely different happens. And this is what kind of a healthy, ecological, biologically diverse landscape does, is that when it rains, that rain soaks right into the land. And it's going down where the plant roots are. It's going down, creating moisture for all of the microbes underground, for those fungal communities, saving it underground for plants for dry spells. It's refilling groundwater. So humans have water to drink. It's not flooding. It's not a drought. But eventually, it may be 3 feet down, it may be 20 feet down, it may be 100 feet down. Eventually, it might hit some bedrock. And what you see there around the edges is that clean, clear, filtered water starting to come up in springs, starting to refill lakes and rivers from below with really clean, clear, filtered water that's gone through both a structural filter and also a biological filter. So no flooding, no drought, much better air quality, because if wind comes along here, the soil is not going to blow away. And what about fire? So if plants are going over here, they have very little or no water at their root zone. So they're only getting whatever water we put on through irrigation. And that's generally not soaking in very well either. If a tree drops limbs or leaves here, this soil does not have the fungal communities that know how to decompose that woody matter. It doesn't have any of the other chewers or shredders or any of the little critters that can take apart wood and leaves and dried grasses. So what happens here is that those plant leaves, etc., and limbs or trees that fall over, they just lie there and oxidize slowly in the sunlight and become drier and drier and more flammable. Whereas over here, we have what's needed to have fungal communities and all of the other little critters that take apart woody material to decompose it and turn it literally back into soil. So where I am teaching from right now is Vermont. And if a tree falls here on the ground, if someone doesn't pick it up or do something with it, it's going to turn back into soil within years, just a few years. Sometimes even within a few months, you can start to see moss and mushrooms growing in it. So here you have a much, much lower fire risk. And there's actually other reasons for that as well, which we're not going to get deep into, but here you're much more likely to get high winds, less so over here, because to grow this, you would have a lot more green leafy vegetation, and that actually changes the wind patterns and the air patterns in the area. So two other views of this. This is with real soils here, not flour and bread. This is, you can see here with the soil that is more healthy, that those soil aggregates are sticking together, because it's kind of like those slimes and glues are like dried raw egg or something like that. That once it's dry, even if you submerge this in water for 24 hours, it's not going to fall apart. Whereas over here, as soon as you put it into water, it just bursts and falls apart. Same thing here. This is this same type of soil, same ratio of sand, silt, and clay particles. But over here, we have all kinds of things being done to grow that soil sponge. So for example, they're not rototilling the soil. They're not compacting the soil with heavy machinery. They're growing plants on it year round and leaving plenty of plant litter, like the broken down plant leaves. Not using biocides, not using artificial fertilizers. Whereas here, they're not using any of those soil health principles. So we've put like 3 inches of rain, maybe 4 inches of rain on here, across here, and these jars are collecting the water that soaks in. You can see here, not a single drop has soaked in. It has all run off and taken a lot of the soil with it. Whereas as you go over to the left, more and more water is soaking in and it's getting filtered. Nothing's running off. This is actually interesting. There's a little bit more soaking in here, but that's because it's running through. Whereas here, you know how some potted plants, you water them and they just, nothing comes out the bottom because it's all soaking into the soil. So here, there's actually a little bit less that's actually gone all the way through because it's more is being held right in the soil itself. And this is clean and clear. You could pick up this jar and drink it. So that's the soil sponge. And you can start to see how this could impact human health in a number of different ways, through air quality, through water quality, through less flooding and less of the issues with housing and mold and the various diseases that can come after flooding, less drought issues and all of the problems with the food system and water system with drought, and fewer wildfires, which also then leads to better air quality. So one other thing here is the toxic algae blooms. I don't know how many lakes and ponds there are around your area and whether they look bright green or bright turquoise sometimes. But when water is running off the top of a landscape, and especially if people are using artificial fertilizers on the farms or on their lawns, we'd have a tendency to grow toxic algae, which can have huge impacts on public health. Both ALS or Lou Gehrig's disease is very highly associated with that. Some association with dementia and with Parkinson's, but also very acute illnesses can develop in people, dogs, or any wild animals or other things that are drinking from them. And in your area, I know that erosion and mudslides can be a big issue, that there's some canyon roads that are closed right now. So again, same issue. If we look at that flower, you could see those mudslides happening there. By keeping those soil particles intact when it's windy out, it's really improvement in air quality. But the other thing, which is sometimes maybe more a little bit further north, but if the soil doesn't blow, it doesn't land on the snow or on glaciers, and that keeps those mountaintops white and keeps the snow and ice there, which creates cooler air temperatures in a number of different ways. Primarily through better albedo. Having a white surface is cooling and absorbs less sunlight, but it also provides a much longer seasonal stream flow down into the valleys. So that groundwater is going to be much more available if the soil is not airborne. Otherwise, if it's all dirty and covered with blowing soils or with exhaust, particles, etc., then you can get very quick spring flooding and then just drought all year long. Since there's more space underground, it's easier for plant roots to grow and for these mycorrhizal fungi to explore. And we get a higher nutrient integrity of the plants. So everything that eats from the plants is improving. And I'll talk about that more in just a minute. The plant tissues are less likely to become diseased or to freeze because it's like a layer of insulation. It regulates the ground temperature. And that's providing air, water, food, and a better climate for all the life underground that makes the sponge, that soaks up the water, that does all these other things. So let's talk a minute about nested intelligences. So what does that mean? If we think about where does health begin? It begins in our ability to decide what should we eat and what should we not eat, right? What does our body need to take in or not? What should we breathe in or not? And most of that is happening not with our conscious mental mind, but it's happening at different layers of the body. And the most essential basic form of intelligence is a membrane, a semi-permeable membrane that decides I need this much water inside the cell and this much out. I need this much sodium inside or this much potassium inside, etc. And so having that intact cell membrane is part of what allowed life to develop. That is basically what life is these cells, right? And then got together and formed bodies. So that's one level of intelligence. And then those cells also form these mucosal membranes. So we have, I think it was Sadhguru was just talking about, somebody was just talking about that in that film. We have a microbiome, we now know, in our digestive system and on our skin and in our nasal nose, in our noses and lungs and in our inner parts of all types, and even in the air around us. But those mucosal membranes are a really important piece of deciding, again, what do we take in and what do we leave out, right? So what part of our food is going to be allowed into our bloodstream, or how much water, and how much do we release out? And one thing we've learned is that it's actually the microbes that are eating. We're not really eating the food. We put food in our mouth, send it down to the microbes, they eat it, and then they pass on the nutrients that we need to us. So if we don't have a good microbial community, or we have a too imbalanced microbial community, that's a layer of intelligence that's been broken, that good decisions aren't being made about what to keep and what not to keep. Another layer of that is through like taste and flavor. So whether it's us in a supermarket trying to decide what to buy or what to eat, or whether it's a cow on a pasture or in a feedlot, the having choices that are sensory choices allow us to develop health, right? So if there's a cow in a feedlot, or a pig or a chicken or any other animal, and they're just being given one or two things to eat, that's what they have to eat. But if they're out in a very diverse ecosystem, the work of Fred Provenza is just incredible. He wrote a book called Nourishment, and there's a book about him called The Dorito Effect that shows that grazing animals know what to eat, when and how much, and what they can eat before another thing. They might be able to eat this much of a poison plant as long as they eat this other thing afterwards, or if they eat this other thing before. And depending on what illnesses they're dealing with or what's in the environment, they will pick and choose very, very, very carefully and teach their offspring to do the same. So then we also are supposed to be doing the same thing with our food sources. Or we are supposed to be eating animals that have done that and pre-selected, or eating the animal, butter or cheese, etc., or eggs from animals that have been able to do that. So whether or not you're a vegan or omnivore, being able to eat from foods that have had this selection process is key. And one of those places that happens, that is like a membrane layer, remember those mycorrhizal fungi that I showed you that are underground, those little threads? Those are like an extension of the plant roots that goes out like a grazing animal or like a person out looking in their refrigerator for something good to eat, that says, I think we need a little bit of copper and a little bit of selenium, but not too much of this over here. And how about a little calcium? And hey, microbes, bacteria, could you break down that rock a little bit more because we need a little of this or that? And then we're going to follow it with this other thing. So they are actually just like a grazing animal or a grazing human, looking for the right nutrients, the right flavors and tastes at this right time, that they will then bring back to the plant. And that kickstarts that kind of intelligence in the plant and in the animals that are eating the plant. So it's all nested within each other. It's all happening at the same time. And I think a lot of what we're seeing in terms of the breakdown of public health, of human health in general, of mental health, has to do with breakdowns in these systems that I'm talking about. One of the big ones is the chemical called glyphosate or Roundup that is used as an herbicide to kill off plants at the end of a season, or to dry plants, or to kill weeds in lawns, etc. And that was patented by Monsanto early on as a broad spectrum antibiotic, because that's what it does. It kills off plants and bacteria. And they said, well, it's just not going to have any impact on human health or on animal health, because it's only working with this pathway called the Shikimate pathway that plants and bacteria have. But guess what? 90% of our cells in our body are bacterial cells. And that's that layer of intelligence in our guts. And guess what else is that those gut bacteria produce like 90% of our brain chemicals and our neurotransmitters and our hormones and all the things that we help us make good decisions. So that's rampant in our food system, in our water, and in our air. And we are also eating food where there are only monocrops grown, so there aren't these plant to plant and plant fungal relationships going on. And if we do eat any animal products, we are tending to eat animals that are not in contact with the land, so they don't get to make those choices. And so then whatever we're getting from those nutrients is just whatever the person who was feeding them decided to feed them. And those are grown from plants that didn't get to have those fungal relationships to help them know what they needed when. So I think a lot of what we're seeing in public health and human health, and also biological, ecological health, has to do with the breakdown in all this whole series of choice points in the ecosystem. Okay. So the soil sponge also soaks up rain and filters water and reduces flood and drought and fire risk, refills groundwater wells and springs. It stores that water underground for plant growth, photosynthesis, transpiration, which is like plant sweating, and kickstarts the water cycle, the carbon cycle, and through those two, climate regulation on land. So let's talk about the climate for a minute. There are two ways to cool off what's cooking on the stove, right? How do you cool off what's cooking on the stove? If you've got a pot that's boiling over, like our climate is.
You add ice.
Oh, that's a good one. Yeah, actually there may be three ways. Yes. Yep, you could add ice to it. Lauren is saying turn off the heat. And what's another way? If you have a pot with a lid on it, you could take the lid off, right? And let some of that heat escape. So when we think about the climate, there are the atmospheric gases, and that's what we always hear about with climate change, is that the greenhouse layer has too many greenhouse gases in it, too many CO2 molecules, too much methane, etc. And that is keeping our planet too warm. And that is correct, that is one big aspect of climate. The other aspect of climate that we don't hear about is the land use piece, the land surface. And so the greenhouse effect is like the lid on the pot, and the land use is like turning down the flame. Beth, are you turning on your camera because we're running low on time? I see we are close to 4 o'clock.
Sorry, no, I'm turning on my camera because I just wanted to make sure you knew there were people here.
Okay, a friendly face. I appreciate that. Yeah. Yes. Anybody who wants to turn their camera on, I always like to see your faces. So, okay. So let's talk a little bit about the cooling aspect here. So if we're talking about the greenhouse effect, plant growth or photosynthesis takes that CO2 in the atmosphere, and it takes water from underground and it turns it into a plant, right? So more of itself, but then it also feeds itself to all other life, whether it's like something that's eating the pollen or something that's eating the fruit or something that's eating the leaves, or something that's eating something that ate the leaves. And so that carbon, instead of being in the atmosphere, is circling through or being stored in life, or stored in life's residues. So there might be dead plant matter on the ground, or there might be carbon that came out of the plant's roots as sugars, were fed to microbes, and they deposited into those little slimy glues holding together the soil aggregates, and we have longer term soil carbon storage underground. And all of that means that there's less carbon, less CO2 in the atmosphere. Plants also regulate the climate through shade, but through reducing the heat that's reaching the ground. And then if there's less heat reaching the ground, the air temperature is lower because we're radiating less heat back up. But a huge way that plants also influence the climate and the temperature and the weather is through transpiration, which is like plant sweating. That when water evaporates, comes up through the plant and evaporates off of the leaves and turns into water vapor, it uses heat to evaporate water, just like if there's heat on your pan and you threw a little water in it, it would quickly evaporate it. And that would cool off the pan as well. So that's a fourth way of cooling off the pan, right? And so in doing that, it's taking that heat that you could feel and turning it into heat that isn't heating anything anymore. So some of the scientists that I work with have said that 40% more transpiration on agricultural land, or 20% overall, could in theory reverse global warming just through transpiration alone. Those numbers are updated because when they actually calculated them, it was 0.6 degrees Celsius warming, and we're now closer to 1 degree Celsius warming. So if you've seen different numbers before, that's why. But I don't know if that's true on a global level because that's sort of a theoretical model. But what we do know is that in a place by place comparison, we can have huge cooling. So now here we're not talking about like 1 degree Celsius or whatever we're at. What are we at in Fahrenheit now? I think it's at 2 degrees or 3 degrees Fahrenheit more overall global warming. We're much more at, we're seeing places like between downtown LA and on the coast where it's 20 degrees warmer, right? And the reason it's 20 degrees warmer is because there are not as many plants there. That's one of the biggest aspects. So one study, this was actually from Turkey, but it really, and Fatima, I'll get to your question in just 1 second. The air above a green transpiring landscape or a green growing landscape is on average 9.5 degrees cooler than bare soil and 21.5 degrees cooler than pavement. And this is even with air mixing, right? Because there's cool winds blow in from one place and whatever. If we look at the actual surface of the ground, you know, I've seen here, even in Vermont, where it's a pretty moderate climate, if you take one of those handheld laser thermometers and point it at green leaves, green growing grass, it might be 75 or 80 degrees. And if you point it at bare soil, it's like 110 or 120 degrees. And if you point it at pavement, it might be 160 degrees. So then we're talking about like a 50-degree difference. And we know this because as kids, we ran around barefoot, many of us. And we knew that if you jumped from the pavement onto some mud, you'd be cooler. And if you jumped from that mud or dirt onto grass, you'd be even cooler with your bare feet. So a lot of this we know in our own bodies already. And we just don't think about, well, wait a minute, we know about heat dynamics on the planet. We've experienced them all the time. We know that when we sweat, we can cool off if we put a fan on us. And the same is true of plants. Okay, Fatima, I want to hear what you're thinking.
Hi, Didi, I really wanted to say thank you for the analogies. They kind of put it in context more easily. So what I'm thinking, so you know how Dubai does cloud seeding? And is there a way to do something similar with the carbon layer?
Yes, so wherever we plant plants, we'll take that CO2 and put it into the plant. So people are trying to do all kinds of technological fixes of sucking carbon and extracting this, you know, sucking air and extracting the CO2. That's exactly what plants do. So
we could we could technically do that and use that carbon to help our plants to grow.
the plants do it themselves. We don't even, all we need to do is plant a seed and add some water and let it grow. And it will do that. And so it will cool the climate through the carbon cycle. Every plant that we plant, everything that we let grow larger, even if it's out on your balcony, all of that is taking carbon and turning it into life. But it's also cooling the air. So an average like urban tree is the equivalent of 2 air conditioners running. And it's not putting that heat out like a plug-in air conditioner. It's taking it and that heat is not back in the air until it's way further up till it turns into a cloud. So then that heat can escape out to space. So we can cool the climate through the carbon cycle and through the water cycle. And that's just, we don't have enough time today to go into all of the different forms of cooling. But the big message today is that by having diverse plants growing wherever we possibly can, whether it's a rooftop garden or a tree in your neighborhood or even a little box on your balcony, all of that matters. All of that helps to cool both your neighborhood and the climate as a whole. Yes, Denise?
Thank you.
Yes, great question.
Hi. Well, thank you. First of all, I feel like I'm having an anxiety attack, but this happens every time I watch or listen or learn something about the short time we have left. When you were talking about soils becoming more sandy and so they can't sustain life, is there any way we can convert them back?
Yes. The amazing thing is that all soils need to convert back is plants growing in them, diverse plants growing in them. And Denise, leave your camera on so I can keep talking to you.
Wait, you can? Oh, sorry, I look awful.
No, it's okay.
Like every day. But you're saying even if it's sandy, you can put plants in that soil and
and so it may, you may need a few other things going on. So you might need some compost, you might need certain kinds of plants that can grow in those conditions. You might need to be watering it more often than some other things. But plants will grow soil. And that's one of the reasons that we see weeds like grow, you can look even on the highway, sometimes you see like a plant growing out of the concrete, right? Whatever can grow will grow. So there are plants that are adapted to grow in every possible condition. And we need to look and see what is already growing here, because anything that is growing, for the most part, this is not, maybe not 100%, but 99% of the time, it's the thing that knows how to convert that degraded soil into a little bit better soil so that the next kind of plant can then grow.
Thank you.
Is that another question, Fatima?
Yes.
Yes. Okay, go ahead.
Okay, I have a radical idea. So
Yeah.
I know parts of the LA River, well, the LA River is concreted over. Parts of it, they have taken out the concrete. And is that an answer? Like, I'm just wondering how to
Absolutely,
make.
yes. Yes, depaving, whether it's the river or it's you know, somebody's yard or parking spot, you know, in their yard. Depaving it and allowing things to grow or planting some things is really critical. Now I know that, you know, in California, especially during the drought, they were really encouraging people to take out the grass and put in rocks, right? But if you look at those temperature things, right, the rocks are the equivalent to pavement. So when we change from living plants to rocks, we are increasing the air temperature there by maybe 20 degrees, maybe even more. And if we do that all over the city, we're really increasing the temperature throughout the city. So it's a very short-term idea of saving water, but what we saw with the soil sponge, right, is that we need the plants to create the soil sponge, and we need the soil sponge to hold water to grow more plants. So we need to get going in that direction rather than the other direction. So whatever water we do have that's extra should be used to be growing plants. And I just heard this morning that in Santa Monica or somewhere in that area, there is a shopping center, there's a wetland being drained to create a new shopping center, and they're pumping, I think it was 2 million gallons of water a day out of there to just get rid of it. So if you think that you don't have water in your region, you're wrong. It's what are we using the water for? And also, the humidity today is like 75–80% there. That's water vapor that's in the air that if you have the right capture technologies, including plants, can take that vapor and actually turn it into dew under the right conditions. Or you can do things with different, you know, rooftop metals that will capture it and condense it and put it into liquid water that you can then drink or that plants can drink. So there are a lot of different ways to access water, to capture water. There's rain barrels, you know, all of that rain that just fell in California, how much of it actually stayed in the soil? But we can change that.
So Didi, I wanted to check in to see if you had more you wanted to share before we went on. I see a lot of questions coming in. So we have until 1:30. I don't know if you wanna continue.
Yeah, let me
answer questions.
I'm gonna just look quickly at my slides and see if there are things that are really key that we didn't get to talk about. Let's see here. Here, I'll sort of, yeah, there's a few here that I think would be good. Let me just
Okay, so
quickly
I'm
do
gonna
this.
ask,
Yeah.
I'm gonna let people know we're gonna answer questions. If you want to put your questions in the chat to make sure we hear them, that's great. If you want to wait probably 10 or so minutes, I promise.
Yeah, maybe not even 10, maybe just
5
5.
or 10. Okay.
Yeah.
Thank you.
Sure. So I have 3 goals here that I think are, if we want to kind of think about action points, that just in terms of the cooling through transpiration, not even talking about the carbon piece, which I see there's a lot of interest on that as well. That if we could increase photosynthesis by 20% overall or 40% just on agricultural land, that would take care of a lot of our issues of of biodiversity, our issues of cooling, our issues of carbon, all of those things. We can achieve this a few different ways. One is by plant density, simply having less bare ground, right? So if you see bare ground, that you put plants on it. We can achieve it by increasing plant diversity or leaf structure. So if you have just simple grass, then you plant some taller things in there that have different leaf structure. We can achieve it by having taller plants, right? So if you do have a lawn and you mow it to 1 inch, let it grow to 3 inches. And I understand that you have fire risks. If you're going to let it grow longer, you need to make sure that it has more water and that you have a way to get that water to it. And then the fourth way we can do that is by increasing the length of the green growing season. So because you tend to have a more seasonal wet season and a dry season, if it's agriculture, you can delay when the cover crop is terminated or harvested or tilled. You can use more perennials. So rather than growing corn for cows, you can grow hay and cut it, and then you leave some. Or in your own garden, having more perennial plants. So plants that keep growing year round. Using plants that know how to work in the current conditions. Like I said, a lot of those things that we think of as weeds are plants that can grow under the difficult conditions. But the fourth one is really key here, is by growing more plants, we will grow the soil sponge structure and function, which will then soak up water, which will lengthen the green growing season. And there are places in California where people have worked on this through all of these, and they have a much longer green growing season than places that don't. So particularly in grazing operations. Okay, so that's one goal. Another goal is to feed and protect the soil sponge. So in order to keep the soil sponge regenerating continually so that it does keep soaking up water and providing all those benefits, we need to keep it covered with living plants and also plant leaves or mulch or things like that that are up underneath the living plants. We need to reduce or eliminate any physical stresses, so not breaking up the soil sponge with a rototiller, not compacting it by driving heavy machinery over it. And we need to reduce or eliminate chemical fertilizers and biocides as much as possible. So biocides is what's typically called pesticides, because there's a workforce there that is creating all of these benefits. And if we're just continually killing them off, we don't get those benefits, nor does anybody else in terms of the whole workforce of life. So goal 3 is to invite all the workers to the table, to the farm table or to your yard or to the campus, and don't kill them. So provide food for all of life, provide habitat for all of life, provide good working conditions for all of life, and to balance nature with nature rather than using like insecticides. So people spray for insects. When you use an insecticide and you kill all the insects, you're killing the insects that eat plants, but you're also killing the insects that eat other insects. So for every insect that eats like your apple tree or whatever you're trying to kill off, there are like 1,700 insects that are beneficial. So when you kill all of them off, the only one who has food left is the one who eats the apple tree, the one who's eating the plants, because the plants are still there. So instead, there are ways of working where we plant plants that bring in those beneficial insects that help to balance the population. Just like, if there are wolves and deer and there are foxes and mice or cats and mice, etc., things eat each other and balance out those populations. But if we kill all of one, then we end up with imbalances. So the last thing I wanted to show you was this group of women in India. It's millions of women in Andhra Pradesh, India, and across India, but particularly in Andhra Pradesh, who have gotten 800,000 farmers, many of them are farmers themselves, to convert to a natural farming system that that is doing all of these soil health principles. Oh, let's see, it's looking very funny. Not sure why it's doing that, but let's see. You probably can't hear the sound, can you? It's just music thing. But you can see here, this is one woman's farm in a place where all of the rest of it looks like a lot of California, right? It's either bare or it's just brown. But what she's done is she has planted a diversity of crops and trees, all different heights. And without using very much water at all, she's able to keep it green year. Whereas everybody else is waiting for the things to grow their food. So by using the principles of natural farming, which is what we were just talking about, she's growing food and capturing water and providing habitat for insects and animals all year. So I just wanted to show that as a possibility, if they can do that in India with, these are very, very poor women who are pooling their savings as a way to get things done and leveraging that for bank loans. And it's really just been done through social organizing among very poor rural women. And they have got 800,000 farmers farming in that way with no chemicals, getting much more water efficiency, much higher yield in crops, much more nutrient dense food. All of their health and their children's health is improving dramatically. Way fewer complications in childbirth, way fewer illnesses. They had lower COVID numbers. All kinds of benefits are coming out of having these natural farming systems. So that's on an agricultural scale. That's what I think is one of the more hopeful systems that I've seen that's really trying to put it all together. And then just invite you that this is actually a free curriculum that's available here. If you go to landandleadership.org under resources, it's there. I think it's listed as the Soil Health Manual. So you can download it for free there. And I'm sure George will put that in the links with the replay. And also here, if you click on courses and sign up, I do teach classes online very frequently and have an ongoing group called the Land and Leadership Development Community that has weekly discussions and case studies with an international group that you might be interested in looking at as well. All right, I will stop there. Thank you very much. And I'm very interested to hear what people are thinking, and not just your questions for me, because I'm just another human being, but your questions for yourself and each other as well.
So Dean has had his hand up for a while. So if you want to,
sure.
Do you want to unmute yourself?
Yeah, hi. I'm writing an article on this workshop for my club, and I've taken a lot of screenshots of like your points, but I never got because I came in 10 minutes later, I didn't get the title of the PowerPoint, and I'm supposed to include images that I was here to confirm that I joined this workshop. So I was wondering if you could do me a favor and
sure,
if you could
yeah,
show
I can
me
do the title
of your...
Absolutely,
Yes.
yes. Let's see, let me get back to that slide. There we go. Let me know when you got it.
Thank you so much. Thank you.
Yes, welcome.
Thank you for that, Didi. And then there's a couple questions in here, and I don't know if people want to raise their hand since we've been unmuting. I think it'd be great.
Yeah, it's nice to hear you rather than just hear from someone else.
Just me. But while we're waiting to see if that's the case, there was a question in here about kind of two questions about, one is so the weeds that people are growing are helping the environment. It's kind of a question. And then also what plants did you recommend might be the most efficient at taking up carbon?
So So the question about weeds, first of all, yeah, there's a lot, there are a lot of different opinions about weeds or so-called invasives. And it's just as many questions and opinions as we have about when people move from place to place, right? Or go somewhere that they haven't historically lived before. So, and very often it's because they're the people who know how to do something, who have figured out how to get there and can live there better than where they were living before. So I think we can easily get into trouble when we look at something with a judgment of, is this good or bad, or should I kill it or not, or should I get rid of it or not? And it's more of a question of, what is the role of this in this place right now? Like what can this serve in terms of the whole system right now? Which I think is also the right question when people arrive somewhere, is, okay, what would you like to do here? What skills do you already have that you might be able to bring to our community, and how can we help you? So looking at plants that way, I think, is a different approach. And yes, there are some situations where certain plants can grow so well that they shade out all of the other ones, and it becomes kind of a monoculture. And usually then what's missing is not an herbicide to kill those plants, but what's missing is some animal that likes to eat that plant. And sometimes human intervention that, humans have maybe used that plant for a building thing or something. And that, for a long time, people used to cut it back with a machete, and now people don't work that way. And so they're using herbicides, but those herbicides impact the health of the whole system itself. And a lot of the narrative about invasive species is being pushed by the company that sells those chemicals. So we just have to have some critical thinking when we look at that.
There's a hand up. Thin Eddie has a hand up. You can unmute yourself.
That might have been the same. Okay, I think that was the same question from before. Yeah.
Okay.
Okay, so then the question about which plants are the most efficient at taking up carbon dioxide. Well, we can kind of tell that by which plants grow the most quickly, right? Because that's how plants grow, is they take CO2 and they take water and they grow. And we think of plants as being made out of soil. A lot of us grew up thinking that, but in fact, plants are made out of air, and so are we. Like most of what isn't water in our bodies and what isn't water in the plants is mostly carbon that's come out of the air. So any plant that grows quickly is going to be taking up a lot of carbon dioxide. But there's a second important question, which is, how long does that plant last? Because if it's a plant that grows quickly but then is burned, like corn as a biofuel, then that carbon is going back to the atmosphere. So corn grows really quickly and takes up a lot of carbon. In fact, the CO2 levels are very low in a growing cornfield on a sunny day. They're much lower than anywhere else. But as soon as we burn that, or even burn it and use it with our own bodies, it's going back into the air. So a fast-growing tree that we're not cutting can take a lot of CO2 out of the atmosphere and provide a lot of transpiration. So any plant that's growing quickly is also transpiring quickly. But for example, again, back to the cornfield, that's great for part of that, growing season, that it's using a lot of CO2 and transpiring a lot, et cetera. But then typically those cornfields would be bare the rest of the year. And then that's collecting all of that heat, and there's no CO2 being used there. So it's not a totally simple question. And usually it's more, what we're looking at is not to find the right plant, but to grow a diverse system, because to build the soil sponge that can keep growing those plants and that can keep providing us with water takes a diverse plant ecosystem. And that diverse plant ecosystem also feeds the whole workforce above ground. So all of the pollinators, all of the different insects, all of the different birds and mammals, et cetera, we need a diverse plant canopy.
So are there, Anybody else? I didn't see another question come up in the chat. And I don't know if anybody else raised their hand, but I have are palm trees good for the environment?
Yeah, again, it's sort of a similar thing. If a palm tree is neither good nor bad for the environment. A palm tree is just being a palm tree, right? Like you could say, you know, am I good or bad for the environment? Well, right now I'm just a person, but it depends what I'm doing and in what context, etc. So I was just in another class I was teaching, we had somebody there from Malaysia, and we were looking at the like native forests compared to the palm plantations there. And the native forests are providing all kinds of benefits that are broad because they're, like I was just talking about, they're feeding and providing habitat, etc., for very, very diverse workforce of many different species above and below ground. Whereas a palm oil plantation might be providing a lot of transpiration and photosynthesis, but it's a monoculture, so it's not helping to regrow the soil sponge, not helping to feed the diverse biological workforce that we need. So it's not the tree, it's not that species that is the problem, it's the human desire to make money by growing a monoculture.
So Didi, can we're gonna need to wrap up because we just have a couple minutes, but I want to kind of summarize what I heard you say, which was, I mean, the big thing is that that we have ways we can take action around helping in the climate, helping adjust our climate. And that's really by thinking about the soil and thinking about what we grow and growing and getting our soil and our paved areas or our dirt areas covered with plant material. Is that accurate, would you say?
Yeah. And I think saying diverse plant material, and I think getting really, really curious and relearning with our own bodies about heat dynamics. So going out with one of those handheld sort of laser thermometers, the one that everyone was using during COVID, that you can point at a grass and point at bare soil and point at pavement, and use your hand or use your bare feet and feel the difference. And I have a project that I would love someone in LA to pick up, which is like a bus stop thermometer thing where every bus stop in the city would have a built-in air thermometer that showed what the temperature was there, but would also have one of those handheld ones on a string and some planting boxes and maybe a tree nearby, and that people could, while they're waiting for the bus, play around, but also look at a little chart, maybe on their phone or maybe they're at the bus stop, of what the temperatures are in the different areas of the city. I think people would really start thinking about things and learning and asking some good questions, and maybe there'd be a billboard with some things to think about or activities to do or a website. So maybe you'll take that up.
Yeah, we may well.
I think it's actually quite a fundable idea. We've fleshed it out quite a bit in some discussion groups in that Lolly discussion group. So
that's very cool. Metro is looking at redoing bus stops across the whole city. So they just got a charrette for students to design.
Oh, wow. All right. All right. Well, if you want to invite me into something, I'd be happy to present that. Yeah.
Yes.
Well, thank you, Didi Pershouse. This has really been a very very interesting talk, and it does bring together so many different braids of what we might call agriculture, food, land, biodiversity, climate, all in one incredible discussion. So we're very, very grateful for having you today. And we will we're recording this, so we will actually post this on our website, and people can see this on their own and share it with others, as well as anything else that you might want us to add to the list of publications and links that we have for you. Feel free to drop me an email, and I can always expand on the list of sources and publications. Thank you all for attending today. Our next meeting will be May 16th, I believe, when we talk about expanding climate literacy and climate curriculum throughout the all disciplines. One of our goals is to get the climate science out of the STEM silo and to have it be a commonplace in social sciences and humanities. And work by Didi shows you how important it is to bridge science with different concepts that are found in social science and humanities. So it's a really good example of where we're trying to go with all of this. So thank you again, Didi, and thank you, Adrienne, for hosting, as well as the Climate Center in West LA for sponsoring.